So the very next section is talking about the organization of roots. So remember, roots are everything that's below the ground for the most part, and this is where water absorption and storage of a lot of products from photosynthesis happens. So first, I want to take a look at this picture, which is the very large picture on page 451, and this kind of explains the whole entire thing. So we divide the growing root, so the root's always growing downward, and we divide it into three different sections: the root, the zone of cell division, the zone of elongation, and the zone of maturation. So down here below that, we have this thing called the root cap, and the root cap protects the growing root. It has very tough cells which are constantly being removed as they're pushing through the soil. So it's just constantly like rapidly renewed cells to protect the apical meristem, which is where the cells are actually growing downwards. This is where the differentiation of cells happening right here. So the root apical meristem is found right here, and it's protected by the root cap down here. Then we have right above it the zone of cell division. So this is where cells are dividing and making new cells right here, particularly by the meristem. So this is where new cells are being made in the zone of cell division. Then in the zone of elongation, they are doing just that, becoming longer, just growing. So we're not making new cells up here, we're just growing them right here. And then in the zone of maturation, they start to differentiate and start to do particular jobs. Rather than just being cells, they're starting to actually do the jobs that they will be doing in the root. And there's a bunch of different tissues that we're going to talk about in here. So first we have the epidermis, which is this kind of tannish found all the way around the outside. The epidermis, you should know by now after you watched the last video, its job is to protect and keep water inside, and it consists of only a single layer of cells and roots. And they're usually very thin and rectangular, and many of them have root hairs, because remember, this is where the absorption of water happens, is in the root hairs of the epidermal cells of the root. So you can see here, here's the root hairs, and water moves in through there. Then next, this yellow section right here is called the cortex. And the cortex is where the ground tissue is located. So the parenchyma cells are located in the cortex. And this is, they're very kind of loosely packed, so water can move in between them without having to enter the cells. They're not very tightly packed. Like the epidermal cells are very tightly packed together. Water can't fit through the cell walls. But in the cortex, the parenchyma cells are not so closely squeezed together. Remember, parenchyma cells only have one cell wall. It's very thin. So water can move around them inside the cortex. And the cortex functions in food storage. So this is where we're storing food, in the ground tissue, the cortex, the parenchyma cells of the root. Then next we have the endodermis. The endodermis is this pink layer right here. And the endodermis' job is to protect anything. It's to protect all the stuff inside, which we're going to get to. So it's kind of like the guard between the cortex and everything further inside of the root. And it's a single layer of rectangular cells that forms the boundary between the cortex and everything else inside the vascular tissue. And there's this, your textbook says, layer of impermeable lignin and suberin. So these are tough, suberin is waxy and lignin is very tough, chemicals called the Kasparian Strip. And so the Kasparian Strip is right here. It goes all the way around. And basically what it does is it does not allow anything through between cells. And so it prevents passage of water and anything else. So if anything is going to move inside the vascular tissue, it has to go inside the cells of the endodermis. And what this does is it protects the plant. So out here, water's moving around, going between cells, whatever. In here, we only want good things entering the vascular tissue of the root, because this is going to be pumped to the rest of the plant. So this is like checking the plant's water supply right here. So think about it this way. If you were bringing water in from a reservoir for a city, you would want to check to make sure there's no toxins in that water before you pump it to the rest of the city. So that checkpoint happens at the Kasparian Strip. So if nothing can pass this line without going inside of these cells. So toxins can float around out here, but nothing can move inside here to be pumped to the rest of the plant without crossing the Kasparian Strip. Then inside is the vascular tissue. So this is the xylem and the phloem that's moving water and nutrients throughout the entire plant. So the xylem is very key here because it's bringing in water from the roots with the root hairs and pumping it to the rest of the plant. So this is where the rest of the plant is getting all its water from, is the xylem of the roots. Then the phloem in the roots are receiving sugars for storage. They're going to take the sugars and store them in the cortex of the root. And we have the pericycle, which is this green strip right here, I think. Yeah, the green one right there, which is the meristematic tissue of the root for the vascular tissue. So this can still break off and start like a root branch. So you know how most roots are not straight down, they have lateral roots and secondary roots. It comes from the pericycle right there. So that is tissue that at any point can break off and start forming a new root, which we'll take a look at in a minute. Then inside we have the xylem and the phloem in here. Now in dicots, the xylem is in the middle and it is kind of in the star shape. So you can see it right here. It looks like a star. That's the xylem. And then the phloem is all found around it. So this is a dicot root that we've been looking at. And again, this is where the xylem is bringing in water from the root hairs and pumping it up to the rest of the plant, providing water for the rest of the plant. And the phloem is receiving the sugars that have been made in photosynthesis in the green parts of the plant that are above ground. The phloem is receiving the sugars and storing it in the root. So that's what's happening here. Then we have, so this is what happens if a dicot root wants to branch off. So it starts that pericycle, the meristematic tissue that's found all along the inside. We can't just have it at the apical meristem because then the plant can only grow downward. We have to have it along the entire outside of the root also, that way we can branch offward. So here's the pericycle, and we can see this is it, a root tip growing off of the vascular cylinder. So here's the xylem, the phloem found in the middle. So this is a root tip growing off of this side. Then we have monocot root, and so they are organized differently. So we need to know that. And it says the ground tissue of root's pith is surrounded by a vascular ring. So you'll see what that means. And they have the same growth zones as dicots. So they have zone of cell division, zone of elongation, and zone of maturation, but they don't have secondary growth. So they don't grow outwards the way that dicot roots do. And what we see differently is that it's structured very differently. So we have the same thing. We have the epidermis outside and then the cortex, and then the endodermis, and then that's where it switches. Then we still have the pericycle right here, so it can grow outwards if it needs to. But then we see the xylem is right here, and the xylem is this part right here, and the phloem's right here. So basically they're arranged in rings, and they're connected. They're arranged in bundles. The xylem's right on the outside. Oh, I'm sorry, this is the xylem right here. Xylem's on the outside, and the phloem's right here. So xylem is all surrounding, and the phloem is in these bundles. And there's more ground tissue inside, which is called the pith. So that's very different than how this dicot root is set up. The xylem in the middle and the phloem all around. There's no pith in a dicot root, but we see extra ground tissue in a monocot root, which is called the pith. So those are the differences. But they also still have a pericycle, endodermis, cortex, and epidermis, just like the dicot roots. So there's a lot of different kinds of roots that you need to know about. The first is called a primary root, which is just a normal taproot. It's a single long root that grows straight down, and it normally is very thick and fleshy because it's only one, and that's where all the storage is happening, stores food. Then there's a fibrous root system. Oh, an example of a primary root would be a carrot. You can see pictures of these on page 453. Then there's a fibrous root system, and this is what you guys are probably the most familiar with. This is what's like underneath most flowers and things like that. They are slender roots and lateral branches. So there's been a lot of sideways growth coming from the pericycle. And these help anchor the plant to soil. If we spread off a lot of different ones, it's gonna hold onto the soil as tightly as possible and not let the plant move very easily. Then we have adventitious roots, which are roots that develop, I can't read what that says. Roots that develop I don't know why this is in your textbook. From the organs of the shoot system. So they work as roots, but they come from the shoot tissue, not from the root tissue, but they still serve as roots. They're called prop roots because they emerge from above the soil line and act as anchors for the plant. So they're still acting to anchor the plant to the ground, but they're actually made of the tissue that the stem is made of instead of root tissue. So prop roots, like I said. You don't need to know about that. So that's all you need to know about roots.